Welcome to the DIY Honda Garage channel. The Diagnostic Trouble Codes, DTC P2252 and P2255, relate to low-voltage signals detected from the air-fuel AF sensors in a 2016 to 2022 Honda Pilot. DTC P2252 pertains specifically to the rear AF sensor located on Bank 1, Sensor 1, while P2255 refers to the front AF sensor on Bank 2, Sensor 1. These sensors play a crucial role in determining the optimal air-fuel mixture for efficient engine performance and emissions control, located in the exhaust stream to measure the oxygen levels. When low voltage is reported, it can indicate a circuit malfunction, which could affect fuel efficiency and emissions compliance. It is vital to ascertain the condition of the wiring and connections associated with these sensors, as their failure can impact engine operation significantly. DTC P2252 indicates a low-voltage circuit issue with the rear AF sensor, which is positioned in the exhaust path of Bank 1, Sensor 1. This sensor's role is pivotal. It provides vital feedback to the powertrain control module, PCM, regarding the oxygen content in the exhaust gases, which is essential for achieving the optimal air-fuel ratio. Conversely, DTC P2255 signals a similar problem with the front AF sensor located at Bank 2, Sensor 1. Both sensors are essential for monitoring and adjusting the combustion efficiency and emissions of the vehicle. Wiring or connection faults can inhibit the PCM's ability to read accurate data from these sensors, ultimately affecting engine performance and emissions compliance. Several factors can lead to the triggering of DTC P2252 and P2255. A primary potential cause is shorted wires, specifically in the VSB1 and VSB2 circuits connected to the sensors. Such short circuits can impede the voltage signals necessary for proper sensor function. Additionally, one or both of the AF sensors themselves may be malfunctioning, which would lead to incorrect readings and trigger these DTCs. Lastly, issues within the PCM can also cause this error, where it fails to process and react to the data from the sensors effectively. Ensuring that all wiring is intact and that the components are functioning properly is crucial to resolving these issues. The symptoms associated with DTC P2252 and P2255 can significantly affect the driving experience. One of the most immediate indicators is the illumination of the check engine light on the dashboard, which warns the driver that the vehicle has detected a problem. Additionally, low voltage from these sensors may lead to poor fuel efficiency. Without accurate readings, the engine may not be running at optimal conditions, ultimately wasting fuel. Increased emissions are another concern, as incorrect air-fuel mixture can raise the pollutant levels released into the atmosphere, potentially failing emissions tests. Recognizing these symptoms early can help prevent further issues with the vehicle's performance and environmental compliance. The first step in the troubleshooting process for DTC P2252 and P2255 is to turn the vehicle to the on mode. This action activates the vehicle's electrical systems. Following that, the next action is to clear the DTCs using the HDS, or Honda Diagnostic System, which effectively resets the onboard diagnostic memory. After clearing the codes, it's important to start the engine and hold the engine speed at 3,000 RPM without load until the radiator fan activates, then allowing the engine to idle for an additional 2 minutes. This sequence is essential for the sensors to stabilize and return valid data. Finally, check for any pending or confirmed DTCs again, using the HDS, ensuring that the initial issue is either occurred or resolved. This step lays the groundwork for further diagnostics based on the results. In Step 2 of the troubleshooting guide, the vehicle must be turned off to ensure safe handling of the electrical components. Once off, the next action involves jumping the SCS line using the HDS. The SCS, or Service Check Connector, is a safety measure that helps to prevent unintentional activation of certain vehicle systems during diagnostics. After waiting for more than 1 minute with the SCS jumped, disconnect the relevant connectors, including the PCM connector C and the A/F sensor's 6P connector. This allows for an accurate continuity test. It is then crucial to check for continuity between test points by measuring either the wires from the PCM to the A/F sensor, or ensuring a solid ground connection. Establishing this continuity is imperative in determining whether the wiring has been compromised. Step 3 involves reconnecting the PCM connector C after completing the previous continuity checks. This ensures that the diagnostic system is once again integrated and ready for testing. Next, it is necessary to exit the SCS mode with the HDS to resume normal operations. It's crucial to start the engine again and hold it at 3,000 RPM, similar to Step 1, allowing the vehicle to stabilize. Now, the focus shifts to measuring the voltage between the specified test points, where one is associated with the rear AF sensor and the other with body ground. This measurement will indicate if there is an appropriate voltage, ideally around 0.2 volts or less. If the voltage readings show acceptable levels, it implies that the PCM may be faulty, or there could be an issue with the sensor's feedback. If the reading is normal, replacement of the AF sensor may be necessary. After completing the necessary repairs, the final verification step is to recheck for any diagnostic trouble codes, ensuring that DTC P2252 and P2255 have not returned. This is essential to confirm that the earlier issues have been effectively resolved. It is equally important to ensure that all symptoms, such as the check engine light, remain off, and that fuel efficiency and emissions meet the manufacturer's standards. Additionally, monitor the performance of the AF sensors to ensure they are functioning correctly and providing accurate data to the PCM. This confirmation process solidifies the integrity of the repairs conducted and promotes vehicle reliability and performance. Once all parameters check out, the vehicle should be good for safe driving. To prevent the occurrence of DTC P2252 and P2255, it is advisable to perform regular inspections on the AFAT sensors as part of routine vehicle maintenance. Periodic checkups can help catch potential problems before they escalate into major issues, resulting in costly repairs. Additionally, it is essential to examine the wiring connections leading to these sensors, ensuring there are no frays or loose connections that could lead to signal interruptions. Timely servicing of the engine also plays a crucial role in maintaining overall vehicle performance. By following these preventive measures, the longevity and efficiency of the emissions system can be preserved, ultimately benefiting both the vehicle owner and the environment. In conclusion, understanding DTC P2252 and P2255 and their implications on vehicle performance is essential for effective diagnostics and repairs. Following the specified troubleshooting steps methodically can lead to accurate diagnoses, ensuring proper functionality of the AF sensors and the overall emissions system. Lastly, conducting regular maintenance, including inspections of wiring and sensor conditions, can prevent the recurrence of these errors and promote long-term vehicle health. Awareness and proactive measures play a critical role in maintaining not just performance, but also compliance with environmental regulations. Armed with knowledge and proper procedures, Honda Pilot owners can ensure their vehicles operate efficiently and effectively. Please like and subscribe to the channel. See you next time.